Okay, in this video, we're going to go over how to solve different types of triangle similarity problems. And I'm just going to have three different examples for you. These are three of the most common types of problems that you'll see, although there are plenty more, so I really can't possibly cover them all. But I want to give you some strategies and just some ideas on how to look at these types of problems, okay? So let's look at this very first one. It's basically having a triangle where we create some kind of a line segment that cuts the triangle into two different parts. Now the first thing that we should probably do, before you start reading all this, the first thing we should probably do is try to determine whether the two triangles that we have created are similar or not. Now what are the two triangles? Let's identify them. We got the large triangle, right? And then by putting this line segment through here, and sometimes you put it from midpoint to midpoint, and we know that, for example, those create parallel lines, right? That's part of the definition. But the other small triangles right here, this particular line segment is not to the midpoint, okay? Are these two triangles, the small one and the large one, similar? Well, let's see. Well, I know that one similar angle is this one down here. It's an angle for this triangle. It's also an angle for this triangle. So we know that there's one angle in common. But here's the other thing that we know. When I do draw a vertical line through the triangle, right, they are parallel because this is a vertical and this is a vertical. So I'm creating 90-degree angles here by doing that. Therefore, they're parallel. If they are parallel, this line that goes through, or this line that goes through both of the parallel lines, is called the transversal. And you remember that when you cut a transversal through two parallel lines, you create corresponding angles, right? So that we know that this angle and then this angle are corresponding, which means that they're equal. So we know that the small and the large triangle, by the AA, angle-angle similarity theorem, are similar. If that's true, now we just set up our proportions, right? Now we knew that this is 15, we knew this was 10, that was a given. We knew that this was x, we knew that was 15, that was a given. So we know that 15, this side, opposite this angle, over the whole long leg, which is 25, add these two, 15 over 25 should be proportional to x over 15, side opposite over the long leg. Sure enough it is. Let's go ahead and solve it, do our cross products. We know that 25 times x is that, 15 times 15 is 225. Divide both sides by 25 and you get x is equal to 9, right? So that's one example of a type of similarity problem that you might encounter. All right, let's try another one. Now with this one, we have two triangles basically, right, that have been connected at one of the vertices, right? So consider this line and this line as crisscrossing lines. And again, we know from one of our way back in the beginning of geometry, we know that when you have crisscrossing lines, these angles are called vertical angles, right? And vertical angles are equal. So we know that we have at least one angle that's the same in both of these triangles. Now we also have the same situation as we did in the previous problem. We know that this line and this line, according to this, are parallel, right? And you have these little markings to indicate parallel. If they are parallel, then this line is a transversal as well as this line. Now, instead of corresponding angles, though, we have what are called alternate interior angles, right? Because this one's on this side, this one's on this side. So they're alternate interior angles. Again, we have two angles that are the same. This one, this one, this one, this one. So again, by AA, angle, we know that these two triangles are similar. So that's one way of actually figuring out similarity. I want to show you another way on this particular problem. This one's actually kind of fun. We were actually given the sides as 1, 2, and 3. And we were given this side as 3, 6, and 9. Are these triangles similar by just knowing those numbers? So what I wanted you to do is to create three proportions, right? You can see what I've done here, but I'm just going to do it again up here. Create three different proportions. And I want you to start with the small number and increase. So it goes from 1 to 2 to 3. So write down 1 to 2 to 3 in the numerator for one of the triangles. It doesn't make any difference whether it's the small one or the big one. I want you to do the same thing in the denominator with the other triangle, 3, 6, and 9. So I put in 3, 6, and 9. Now by doing it that way, what I'm doing is I am corresponding the correct side with both triangles, right? So this side and this side are corresponding. This side and this side are the corresponding sides, and this side and this side are the corresponding sides. And I have something even more that I've seen from my information. They're all equal to 1/3. Now when you reduce it, which means basically that they're proportionate, therefore they are similar triangles. The other piece of information that you get doing it this way is that if you reduce it to the lowest fraction possible, the 1/3, that's called the scale factor. Okay? That basically means that this triangle is 1/3 the size of this one, or this was 3 times larger than that one. And that's a nice piece of information if you do it in this technique. Okay? Let's look at the third type of problem. And that's where you have two basically disjointed or not connected triangles, right? So they look like they're kind of the same, but we're not quite sure. Is there any information that we can glean from it? Now, what we have here is that one of the angles is the same. Okay, so we do know that at least there's one angle that's the same in both triangles. But we also have a side of 33 and another side of 35, another side of 28, another side of 30. Now that seems like it might be somewhat similar, right? But this is what you need to do. We know that the angle is in between the two lengths, right? That type of an angle, and so is this one over here, that type of an angle is called an included angle. Included means it's included between the two different lengths. Now, if it were out here, it would not be included, right? Because there's an angle that's unidentified, or excuse me, there's a side that's unidentified, then the angle itself, so you can't use it. In this case, they're both in the same place in both triangles. Again, might indicate similarity. So what we have now is a possible proportion. So let's set up a proportion the way it looks here. So we can go from 33, included angle 35. So we can set up 33 is to 35 as, let's go to the small one, 28 is to 30. Now, are those proportions the same? Well, when I actually put in 28 over 30, I got 0.933 in my calculator. And when I put in 33 over 35, I got 0.943. These are not the same. They have to be exactly the same number. So these are not proportionate. They are not similar triangles. Okay, so I hope this was helpful in indicating different strategies that you can use to indicate whether two triangles are similar or not.